Today we're going to start chapter number 3, and we're going to talk about the cycles of the moon. And we always start the chapter with a guide post. In the previous chapter, you studied the cycles of day and night and the cycle of the seasons. Now you're ready to study the brightest object in the night sky. The moon moves rapidly against the background of stars, changing its shape and occasionally producing strange events called eclipses. This chapter will help you answer 4 essential questions about Earth's satellite. Why does the moon go through phases? What causes a lunar eclipse? What causes a solar eclipse? How can eclipses be predicted? Understanding the phases of the moon and the eclipse will exercise your imagination and help you answer an important question about science, about how science works. How do scientists get from raw data to an understanding of nature? Now, with this, basically, once we finish this chapter, you will have a current understanding of how we view the moon, the sun, and our location in the Milky Way galaxy and then in the universe. Now, the outline, it will be basically the changeable moon. We'll talk about how the moon moves or the motion of the moon, the cycle of its phases, and then we're going to talk about the lunar eclipses and what causes them. And then we'll talk about solar eclipses, and then we'll talk about predicting eclipses. So we'll see how these things are done. So we'll start with the first part, which is the changeable moon. So now we're going to look at how the moon orbits the Earth. And in the last lecture, we talked that the Earth basically orbits the sun. So the moon basically orbits the Earth, and it completes, that means it starts from a location and then it comes back to the same location in 27.32 days. And this is what we call the sidereal period. And here you can ask questions. You say we have a lunar month in our Hijri calendar, and it's always 29 or 30 days. So how come you say here 27.32 days? And we call this the sidereal period of the moon. That's basically one full revolution around the Earth. So if we start from a location where the sun, the moon, and the Earth are in one line, we call this a new moon. That means when the sun and the moon are in one line from our location here on Earth, we call this a new moon. Now, when the moon comes back to the same location in space relative to the stars, and I want you to look here at the Scorpius, and you look at the Scorpius here. That means the moon has come back to the same location relative to the stars. Well, it's the sun is not really in line with the moon. So in this case, we did not really, the moon did not go from a new moon to a new moon. So in this slide here, this is where you're going to get another new moon when the sun and the moon line up. But when the moon completed one full revolution around the Earth, it did that in 27.32 days, and we call this the sidereal period of the moon. Now, but as I told you, you always say that the lunar month on our Hijri calendar is 29 days or 30 days. And we do that if we go from a new moon to a new moon. So you look at the situation that we have here. That's where the moon basically starts from its position relative to the stars. And then it will come back to this location here in 27.32 days. And that's what we call the sidereal period of the moon. Now it will go around and then it will move a little bit extra. This is to basically come to the location of a new moon. But this basically requires a period of 29.53 days. And that's how we look at the moon. We look at the phases of the moon, and we say that the month is 29 days or 30 days, because going from a new moon to a new moon takes 29.53 days. So if we look at where we started from, where you have the moon and the sun lined up, this is in the last slide we said when the moon comes back to the same location relative to the sky. Look at what we have at the Scorpius. Okay, you look at the where it's coming, and this is basically one full revolution, and this is what we call the sidereal period of the moon, and it takes 27.32 days. But if it comes back to the new moon again, where the moon and the sun and the earth are in one line, where we call this a new moon, that's when you actually need a period of 29.53 days. And this is what we call the synodic period of the moon, which is roughly, when we look at a month, which is about 30 days. So when we talk about the moon, we basically talk about two periods of the moon. We talk about 29.53 and we talk about 27.32 days. And if you check in the internet or you check in a book and you want to look at the period of the moon, and they will tell you the period of the moon is 27.32 days. And that's basically completing one full orbit around the Earth relative to the stars. But we look at the moon by the phases it makes, and that basically needs the period of 29.53 days. So when we look at the moon, you have these two periods, either the sidereal, which is relative to space, or the synodic, which is 29.53 days. And I hope this will become clear as we move on. So for example, you look at the situation that we have here, which is the sun, the moon, and the earth. That's basically a situation where you have a new moon. And then again here, when you have the sun, the moon, and the earth in one line, and that's basically another a new moon. So why is that happening? I want you to pay attention now to what we have here. When you look at the sun, and this is the earth and this is the moon. Now this is basically the yellow arrow here tells you that we have a new moon when the sun, the moon, and the earth line up. And I want you to look at the blue arrow here. This is where it's going to complete one full orbit. So this is the location which we call sidereal month, which is 27.32 days. As the moon goes around or orbits the earth, it will come back to this location relative to the sky. And when it does that, basically you will find that it's not lined up in a new moon. So it has to move a little bit extra, and that's the extra time that we talked about. That's when you end up getting in line or a new moon. And that's the period of 29.53 days. And since we are living here on Earth and we look at the moon, we really cannot tell its location relative to the stars or the space, but we can look at the faces that the moon makes, and we can basically tell from that. I think the ancient Babylonians and Egyptians, especially the Egyptians, they noticed that the flooding of the Nile comes at a certain time. So from the moon, they decided basically the month is about 30 days. And that happened more or less every 12 months. So they use that as a calendar as well. So this cartoon here, it's a different cartoon where it shows you that when the sun, the moon, and the earth are lined up, and that's a situation for a new moon. As the earth orbits the sun, that's also here where you have the situation where we have the location of the full revolution, where we say X here, and this is basically the sidereal period of the moon. But when it moves extra and it lines up with the sun, that's when we have the situation for the new moon, and this is where we're going from, or the lunar cycle. Okay, so that's the idea. Okay, so when we look at the moon, we're either looking at this 27.3 days, so that's where you're actually going to get to here, 27.32 days. And when you come here, it's 29.53 days. So new moon to a new moon, it's 29.53, but completing an orbit, it's 27.32 days. And that's how the moon basically orbits the Earth. By the way, in the same token, you may actually hear when we look at the day as well, the sidereal day and the solar day and so on. It's the same thing that when the Earth is rotating around its axis and it is revolving around the sun, and that will make a difference. And I think the difference is about 4 or 6 minutes, something like this, between the sidereal day and the solar day. And you may also hear that. It's in the same way as the Earth is completing a revolution. It will not be facing the same point, so it has to move a little bit extra. and this also give you a difference when we talk about sidereal day and so on. So we can look at it in the same way as well. So this is how the moon orbits around the Earth. The way we look at the moon, we see the moon that makes different phases as we look at it. Now, the Earth itself, as we discussed, is a planet, and the planets basically they do not make any, they do not produce any light. They only reflect sunlight. The same thing happens for the moon. It only reflects sunlight. So when we have a new moon, the half of the moon that's basically facing the sun is not going to reflect any sunlight to us, and the other half that's facing us, it's not going to be basically getting any sunlight, and that's why at the moment of a new moon we're not going to see any part of the moon. But when there is a full moon in this situation here, when actually the moon is opposite to the sun, so the half of the moon that is facing us, it's receiving sunlight, and that's why we see a full moon in the sky, something like this, a disk. The moon is a sphere, but we do not see the sphere. Okay, we only see that disk like the sun itself. And this is basically when we have a full moon. When the moon basically at this location here, and that's what we call a quarter or first quarter moon. Well, in this location here, the half of the moon is facing sunlight, but what's facing us, it's not the whole half, it's only quarter of that. And that quarter to us basically looks something like this. So basically, if you have something like that, and this is basically half of it, that's what we see. Okay, so you can basically draw this into 3 dimensions, so you can see basically a quarter of the moon. But that 1/4 of the moon, the projection of it, it will become like half a disk in the sky, and that's why we call it a quarter moon. That's the name for it. So some people, they say, well, we can call this a half because it's half of what we see in the full moon. Well, the reason we call it a quarter, it's because coming only from we receive the light that basically facing us only from a quarter of the moon. Now, anywhere in between, of course, you're not going to see, you're going to see less of the quarter, and only that portion of the moon that will be facing us, and that's why it's giving us a crescent. And we call that waxing a crescent, and the reason for that, it's going to grow every night till it comes into a first quarter, and then after it becomes a first quarter, it will start increasing, and it will be more than the quarter, and that's why we call it gibbous, and we call it waxing gibbous. That means it's going to increase every night, and then it will become a full moon. And then after it becomes a full moon, it will go on to move, and it will decrease from a full moon. So now we'll have a gibbous as well, but we'll call it waning because it's decreasing. And then we'll get to a situation where we have a third quarter. We only see this section here. And then it will move to less than that, which will be a crescent, and we call it waning crescent. And of course, waning crescent, if the waxing crescent this way, the waning crescent will be the other way. So that's how we distinguish between both of them. So we can say that the moon starts from a new moon, then it goes into a waxing crescent, then it becomes first quarter, then it goes into waxing gibbous, and then it will go into a full moon, and then after that it will go into waning gibbous, and then third quarter, and then waning crescent, and then it will go again to a full moon. And this is basically the cycle or the phases of the moon that we can see in the night or the morning sky. And we'll talk about these times, how we basically get these times. So when it is basically a new moon, you're not going to see anything of that. So now for this cycle, this is the cycle that takes 29.53 days, which is, you can either new moon to a new moon, or you can also look at it full moon to full moon. And that's why the lunar month is 20 days or 30 days because of the 0.53. Because the day, I think from the ancient Babylonians and the Egyptian, they decided on when basically you see sunlight. Of course, the waxing crescent cannot be seen during the day. It's basically seen after sunset, and we'll talk about that. So now, how do we decide on these times of the phases of the moon? So what I want you to do now is I want you to look at a new moon. Opposite to the new moon, you have a full moon. In the middle between a new moon and a full moon, you have the first quarter. And then again, between the full moon and the new moon, you have here the third quarter. Between the new moon and the first quarter, you have waxing crescent, but it choose midway between both of them. Of course, you're starting from here, you will have a waxing crescent, but you choose midway. And between the third quarter and the full moon, you're going to choose midway as waxing gibbous. And between the full moon and third quarter, you're going to use midway as the waning gibbous. And then between the third quarter and the new moon, you're going to choose midway as the waning gibbous. Now make a clock, and the zenith, or it will be basically at the meridian for you here at the highest point. Choose noon time with a new moon. Then midway will be 3 p.m., 6 p.m., 9 p.m., midnight for full moon, 3 a.m. for waning gibbous, and then 6 a.m. will be for a third quarter, and then waning crescent will be around 9 a.m. So that's why, for example, you can see that waxing crescent, first quarter, or waning gibbous can be seen only during the night sky, and maybe part of it in the morning as well for the gibbous. And then these phases are seen in the morning sky. So how do we decide at what time the moon rises and sets? By the way, the choice of noon time, there always be a location on the earth where the new moon might be happening at noon time. We will basically draw a line, and you can see the green line here, and we want to make the face of the moon perpendicular to this. normal. That means you can see the man now standing perpendicular to this line. So the new moon basically perpendicular to this. And you look at this green line here, and you look at the times that are parallel to this. So can you tell me what times are parallel to this? Now, I don't want you to confuse 3 p.m. and 9 a.m. here as being the times parallel. They are intersecting with the line here. But if you draw a line which is parallel to this, you will see that 6 a.m. and 6 p.m. are the times that are parallel to this line here. So we can say that the new moon rises around 6 a.m. and it will set around 6 p.m. and it will be at the highest point around noon time. Now, the new moon, when the Earth, the moon, and the sun line up, this happens to everyone on the Earth. It's not like the new moon will be different for each one on the Earth. No, the moment when you have this alignment, because the moon is orbiting the Earth is orbiting the sun, when they lined up, it is the same for everyone. But what will be different is the time. So the new moon is the same for everyone, but the timing of that will be different depending on your location. And that's why at every location, we can always talk about the moon rising, moon setting, and basically the meridian time as well. Is this point clear? So as you move on, so that's how the moon is moving. It's going always toward the east during the night. So that's east, that's west, and that's how it's basically going to go around during the month. So that's for the new moon. How about if we want to do that for a first quarter? If we want to do that for the first quarter, that means we're going to draw a line where this line will be where the first quarter is going to be normal to it or perpendicular to it. And now you're going to look at the times that are parallel to this line. So if I ask you again, what are the times that are parallel to this? Can you tell me what times are parallel to this green line here in this diagram? What times? Well, it will be, if you look at this, it will be noon time and midnight. These are the times that are parallel to this. So we say that the first quarter rises around noon time and it will set around midnight and it will be at the highest point around 6 p.m. or sunset. So usually when we talk about the first quarter, we say it rises around noon time, it sets around midnight, and it will be at the highest point around sunset. So this phase of the moon can be only seen in the night sky. And we can continue like this when we talk about the full moon. You draw a line which is basically where the full moon is perpendicular to it. and you look at the times that are parallel to this, the times, don't look at the times that intersect with it. You only look at the times that are parallel, which basically make a line like this. So it is 6 p.m. and 6 a.m. So we say that the full moon rises around 6 p.m., which is sunset, and it will set around 6 a.m., which is sunrise, and it will be at the highest point around midnight. And this is what I told you. Remember when I told you that on May 26th, we had a full moon. Also in some places, they witnessed a lunar eclipse, but we did not witness the lunar eclipse here because it happened when we have during daytime for us. So, and I told you that you should look very low in the night sky from the east. That's where the moon will looks a little bit, appears a little bit bigger to you. That's the apparent size of the moon, and we call that super moon. And then I told you if you wait later, you will see that it gets a little bit smaller. I told you at the highest point will be about midnight, and if you look after that, it will be in the west during the morning sky, and of course after that it cannot be seen. So the full moon, you could only see it during dark skies. You cannot see it during the day. And if we continue with this argument here, we can look at the third quarter. And for the third quarter, again, if you draw a line where it's going to be perpendicular to the person facing the third quarter, and you look at the times that are basically parallel to this, you will find it is midnight and noon time. So we say that the third quarter rises around midnight. It will be at the meridian, our highest point, around 6 a.m., which is sunrise, and then it will set around noon time. So you may actually see a third quarter during the day. So that's basically how we look, and that's why I told you should not be surprised if you see the moon during the day. It depends on the time the moon rises and the moon sets and where the moon is in the sky. Now, crescents are very hard to spot because of what? Because of the sunlight, so you need dark skies. So for a crescent, you can only see it after sunset when it is a new crescent. That means waxing crescent, or you can see it before sunrise during the morning sky, but you need dark skies. Now we can basically shift and look at, for example, a situation where we want to look at waxing gibbous. The same thing, you draw a green line where it is basically the observer would be perpendicular to it. And you look at the times as you answer it here. You look at the times, it is 3 p.m. and 3 a.m. So the moon will rise around 3 p.m. and it will set around 3 a.m. and it will be at the highest point around 9 p.m. And that's the time where you can see basically waxing gibbous. And you can continue with that, okay? You can basically do that for waning gibbous, you can do it for waning crescent, you can do it for waxing crescent. Remember, for waning crescent and waxing crescent, we choose midpoint, but we can choose somewhere here, especially at the beginning, when we want to look at the crescent signaling the beginning of the month. And again, you can basically calculate the rising time and setting times. And this is sometimes, if you do that, you will find out that the setting times may happens before sunset. So when the moon sets and the sun basically sets, you don't have background, so you're not going to see it. So we always say you need the waxing crescent to set after sunset. After the sun sets, you have a dark background, and then if the crescent sets after that, then you have a chance to see it. And that's one of the criterion to see a waxing crescent. So this is something that you have to pay attention to. So we talked about how the moon orbits the sun, and we talked about the sidereal period, which is 27.32 days, and we talked about the period from a new moon to a new moon, which is 29.53 days, and that's what we use to see the phases made by the moon in the sky. And I told you these phases are made because the moon reflects sunlight to us. And half of the moon always faces the sun and receives sunlight. So how much of that half of the moon that receives sunlight is facing us? And that's what we're going to see. So when it is a new moon, we're not going to see any parts of the moon. When it's a full moon, we see when a full moon, when it's basically a quarter, I told you that half of the moon is receiving sunlight, but we only see that quarter, which gives us what it looks in our sky as a quarter. And we developed here a clock where we can decide in what times the moon rises and what time the moon sets and so on. Is this clear? Any question on this? Any question on this? Again, when you do this clock, you have to be careful. You're not looking at the times that intersect with the line. You're looking at the times that are parallel to this line. So when you look at this, these are some rules in your textbook. You can memorize them, but I would advise you to use the clock. So we say here, a new moon rises with sunrise, sets with sunset, crosses the meridian around noon time. First quarter rises around noon time, sets around midnight, crosses the meridian around sunset. Full moon rises around sunset, sets around sunrise, crosses the meridian around midnight. And this is the face of the moon that you can always see in dark skies. Okay. You do not see it during the day, or it's not available during the day. Third quarter rises around midnight, sets around noontime, and crosses the meridian around sunrise. And you basically can make a clock like this, where you can basically, as I told you, you decide on the phase. So you start with the new moon, then midway between a new moon and first quarter, you put waxing crescent, and then between first quarter and full moon, you put waxing gibbous, and then between full moon and third quarter, you put waning gibbous, and then between third quarter and the new moon, you get the waning crescent. And you start with the new moon at noontime, and then you start basically increasing by 3 hours. And we talked about the way you decide on what times the moon rises and what times the moon sets. And that's why sometimes you may see the moon during the daytime. So there is no surprise in that, especially if it's a third quarter or something like this. So with this, you know exactly how the moon moves and how you can make interpretation of what you see in the sky. Now here, we tell you that we can see 28 phases of the moon during the month. 14 of them are in the night sky, and 14 of them are in the morning sky. And of course, you're going to say, well, the month is 29 or 30 days. Well, the time when you go through a new moon, you're not going to see that. Okay. And of course, crescent is not easily seen unless it sets after sunset, and it makes the size of the moon that's facing us, makes a good size of a crescent for us to see. So how you basically look at that? Well, this is what you see in the evening sky. In the evening sky, you're going to see waxing crescent, but it will be in the west. And it will be low in the west. So you have to be careful. You really have to go somewhere where there are no obstacle in your way, as high-rise building or trees or something like that. And then you want to look at this, what the first waxing crescent of the moon. And it will be low in the west. So waxing crescent is seen in the west just after sunset, and it may stay there for 15 minutes, 20 minutes, half, it depends. Okay. And it's rising and setting times, but you only can see it after sunset. Then every night, the crescent will be a little bit higher in the sky, and it gets bigger till it becomes a first quarter. And the first quarter, basically at sunset, it will be where it will be at the highest point. After that, it will be basically going toward the east, and of course you will basically see waxing gibbous. You will see 1, 2, 3, 4, 5, 6, and then you will see a full moon, and the full moon will be starting in the east, very low. And that's when you're going to see it a little bit bigger and reddish. And remember about the sun. If you go outside during the day and you look at the sun, it's high, but during sunset, it looks low in the west, and it looks reddish and bigger. It's the same situation for the moon. And that's why I told you to go and look at the supermoon, and I'll explain what the supermoon is maybe in the coming lecture or today, because it's low in the sky, it's closer to the Earth than it usually is, and that's why it may look bigger to us. But the moon is not going to change its size, the moon itself. The name supermoon is a wrong name here. So that's what you see in the night sky, and as you can see, it's moving toward the east. Every night, the moon is going toward the east. So those who have good experience with this, they can basically tell the day, what day we're in. Okay, and sometimes you can correct for the lunar month. During the night or the morning sky, you're going to see 14 phases as well. if we follow the same argument, that means we're going to look in the west. So around sunrise in the west, you're going to see a full moon. Because I told you, the full moon rises around sunset, sets around sunrise. It's at the highest point around midnight. So around sunrise, it will be where? It will be in the west, and you have a full moon. But actually during the night, it starts from the east, and then during sunrise, it comes where? It comes into the west. So if you track the phases of the moon that you can see during the morning sky, this is where you're basically going to see crescent. So the last waxing crescent here will be in the east just before sunrise. So that there is a difference. Waxing crescent can be seen just after sunset in the west, and the last waning crescent can be seen basically just before sunrise in the east. And many can basically tell what time the moon or the month is going to start by looking at this last crescent. So I hope with this we learn how the moon orbits the earth and how the moon makes its different phases, and what phases do we see in the night sky and in the morning sky. Of course, during the daytime, you may actually also see the moon. Now, at the beginning of the chapter, we said the brightest object that you can see in the night sky. Actually, the brightest object that you can see in the sky is the sun. But you do that during the day. So we always say the brightest object is the sun, the second brightest object is the moon to us, because they're very close to us and they look, but there are stars that are much bigger than the sun and they produce a lot more light than the sun, but they're further away from here. Is this clear? Any question on this? Is this clear? Any question on this? Good. The other point that I want to clarify that here, and I will start by saying sometimes people say the dark side of the moon. الجانب المظلم من القمر, or by the way, I'll explain it. There is no dark side of the moon. But there is one side of the moon we always see. And the reason for that, as the moon orbits the sun, it also rotates around its axis of rotation. So I want you to pay attention to this feature here. And this feature here is facing the earth when there is a new moon. This is, we're putting that in just to show you the effect. Okay. Now, as the moon orbits the earth, it is also rotating in such a way that this feature here is going to face us. And this feature here is going to face us. So this feature here is always facing the earth as the moon revolves around the earth. So we say the rotation of the moon around its axis is equal to the revolution of the moon around its axis. And that's why we're always using, we're always seeing the same feature of the moon. It's for this reason. So if you look at the way the moon is orbiting, you can see all sides or all faces of the moon basically seeing sunlight. But the part of, or the side of the moon that's basically facing us, is it receiving sunlight or not? So here in a new moon, we don't see it, but when in full moon, we see it. It's the same thing when you look at this location or this location or that location. So it seems that we always see the same side of the moon. And the other side of the moon is not seen to us because of this rotation, but it's not dark. Okay. So the idea of saying the dark side of the moon, that's, or الجانب المظلم من القمر, that's wrong. But if you say the side that we don't see of the moon, yes, that's true because of this rotation. So as we say here, the Earth exerts a tidal forces on the moon's rocky interior. It is rotating with the same period around its axis as it is orbiting the Earth, and we said this tidally locked. You know about the tides? Well, in Newton's third law, to every action there is equal and opposite reaction. The moon is orbiting the Earth because the gravity of the Earth is pulling on the moon. So you can basically tie something to a string and you can whirl the string around, and you see the object going in a circular motion around where the center is your hand. And the reason for that, because you're pulling on it. So when you look at the Earth, and the Earth applies a gravity on the moon, that's why the moon is orbiting the Earth. And with the same token, that's why the Earth is orbiting the sun, because of the gravity that the sun pulls on the Earth. But by Newton's third law, it's also the same thing happens, that we can say that the moon is pulling on the Earth, and we can say the Earth is pulling on the sun. And the effect of the moon pull on the Earth, it comes in the ocean when you see the tides, okay, المد والجزر. So you have to keep that in mind. So now we know how the moon orbits the Earth, and we know why the moon makes these faces that we see, because it reflects sunlight toward us. And now here we basically know why we always are seeing the same side of the moon. It happens because of what? Because the rotation of the moon around its axis equals the revolution or the orbit around the moon, and that's why we see this. Is this clear? Is this clear? Any question on this? So when it comes to looking at the beginning of the lunar month, especially for Muslims to decide on the beginning of the month and so on, it always has to be with the first crescent. And the first crescent, well, I told you about rising and setting times. Now we know exactly how the moon orbits the Earth and how the Earth is orbiting the sun. We have equations and we have even softwares that basically give you these. So we know exactly when the crescent will rise and when will it set. So if the crescent is setting before sunset, you're not going to see that. So you need the crescent to set after sunset to see that. Now, also, when you look at things, just experience, the further the object are, the smaller the angle it makes to you. And at some distance, you may not see them. So it's the same thing when you want to look at the moon. How much of the moon is facing you during a crescent? And there is a size where you basically is not going to see it, okay? And there is a size where it will give you a size of a crescent like a hair that you can see. And this is sometimes we say, how old is the moon? From sunset, that means how much time elapsed after new moon, how much time elapsed after a new moon around sunset at your location. So it may happen that after a new moon, the size of the moon that's facing you is not going to give you an image that you can see. So you have to wait a little bit longer, but by that time, maybe the moon has set at your location and you're not going to be able to see that. So there are two things that you have to worry about. The crescent has to set after sunset, and then how big is the crescent for at your location that you can see. And we always say that how old is the moon? That means the time of from the new moon at your location. And that's why it depends on location. A new moon is the same for everyone. When you look at the new moon is the same for everyone. But the phases of the moon, no. It depends how old they are relative to you. So sometimes the record for seeing the moon with the unaided eye, that means you're not using telescopes, I think it was around 15 hours, more or less. So the moon has to be at least 15 hours old from the new moon at your location. Of course, it has to set after sunset. With a telescope, sometimes it has to be around 12 hours. That's the record. No one has seen something smaller than this time. And that's why you may hear people saying, how old is the moon? That means the crescent. And is it setting or not setting? So these are conditions that are used. So in astronomy, they use these conditions. Is it setting after sunset? That's good. How old it is after sunset? To give you an image that you can see either with the unaided eye or with aided eye. That means a telescope. And all of these are basically calculated. There is a program called Accurate Times, and there are many softwares that they use conditions, and they can tell you if it is possible to spot a crescent or not at your location. So this is what we usually go through. So sometimes you may actually wait for places where the moon can be a little bit older, and they can tell you we spotted the crescent. And again, light pollution plays a big role here. So you have to go away from cities and so on to see it. And of course, there is something that you have no control of, which basically the atmosphere. If it clouds, dust, and many of the, you have no control over these. So sometimes it may happen within the same country. In some location they spot a crescent, and another location they don't spot a crescent because of these conditions. Crescent usually very small at the first one. It's like a hair, and it's not easy to spot. And of course, Muslims try to look at the beginning of months with this. Of course, as I told you, it's 29.53 days because of this half day. You always look at the 29th, the night. If you do not see it, then the next day will be 30, and you continue and you move on. Are these clear? Are these clear when we talk about the moon? Any question on these? Any question? Okay, good. In the next lecture, we are going to deal with the lunar and solar eclipse and what are the conditions that basically give rise